One day, scientists will be able to manipulate stem cells to regrow any tissue in the body. We're not there yet, but that's where I come in. Specifically, I want to know how to get stem cells to make tendons, ligaments, and heart valves, because these dense connective tissues don't repair well in the body. So when surgeons go to repair them after they've failed, they either replace them with synthetic materials that wear and tear over time and require another surgery, or natural materials derived from animals or cadavers that require a patient to take immunosuppressant drugs. Now, I'm not the only person working on this. There's an entire field of research dedicated to getting cells to make tissues. However, to date, these tissue engineers have been unsuccessful in creating these replacements, or even in reliably controlling these cells. It's well known that we can isolate stem cells from bone marrow and get these cells to transform into the cells that make dense connective tissues. However, it's not as simple as just taking these cells, throwing them into a dish, and waiting. The environment that the stem cells find themselves is vital to instruct them to become our desired cell type. 3 things are critical: the chemical factors produced in the body which interact with the cells, the material that the stem cells in contact with, and the mechanical forces that act to stretch and compress these cells. So if we know that all of these environmental factors are important, then how do we determine which one factor, or combinations of factors, is most important to getting the cells to do what we want? This is the focus of my PhD thesis. I observe the stem cells in different environments to determine what is most effective at getting them to turn into the dense connective tissue cells that I want. In order to achieve this, I grew the stem cells in a jello-like material so that they exist in 3 dimensions, similar to how the cells grow in the body. The advantage of this hydrogel is that I can adjust its stiffness or rigidity, an important aspect of cell behavior. This hydrogel also provides a place for the stem cells to attach, which is important for their survival and identity. I can also manipulate the chemical environment by bathing these hydrogels with cells in different cocktails of chemicals. Now, these things in combination have never been tested before. So with new techniques, statistical techniques, I was able to find valuable information that helped me determine what these stem cells would become. What I discovered was that in 3 dimensions, soft materials greatly influence this transition to a dense connective tissue cell. Although the other factors are still important, we can now prioritize what criteria we need for designing these tissues. The next step is to incorporate mechanical stretch into this platform. And overall, our unique methods allow us to optimize the environment that will get stem cells to make these dense connective tissues. Thank you.